Greetings, physics enthusiasts. Welcome to AP Physics 1, Unit 1, Lesson 8. And at this moment, we are really done with the information on the introduction to kinematics. So with the conclusion in the last video, video number 7, about free fall. So now what I want to do is I want to talk to you about the AP Physics exam itself. The AP Physics exam will happen in May, and you can look up online exactly the date and time of that. Google AP Physics 1 exam and type in the year, and it'll tell you the exact exam date. What I want to talk to you about the exam. AP Physics 1 exam. So there are some things that I'm going to mention now, and then there are other things that we'll get more specific about as the year goes by. But first of all, it has 2 parts. Each part is an hour and a half long, or 90 minutes long. So part 1 is 90 minutes. Part 2 is 90 minutes. There's a little break in between. In both parts of the exam, you will be provided with the equation sheet that I gave you in class. If you lose the equation sheet, just Google AP Physics 1 equation sheet and boom, it'll come up for you. So the first 90-minute section has 50 multiple choice questions. 50. So that's 50 questions in 90 minutes. That's almost 2 minutes per question. So there's plenty of time to think about each question. So you do those 50 multiple choice questions, you take 90 minutes, and then you have a short little break, and then you have 90 minutes for the free response questions. And there's usually around 6 free response questions. Some years there have been, I think, as few as 5, and some years there have been as many as 7 or 8. But anyway, so there's some free response questions. The free response questions are of different kinds, and over the course of our school year, I will talk to you about those different kinds. Sometimes we answer with words and a paragraph. Sometimes we answer the free response questions with equations and calculations. Sometimes the paragraph is asking you to evaluate someone else's explanation of a physics situation. Sometimes those words are asking you to describe an experimental setup. You know, what devices you would use. Would you use a balance? Would you use a string? Would you use a meter stick? So there's different kinds of things that would happen in the free response. We will talk about all of those as the year goes by. But for now, I just want you to know there's 50 multiple choice questions, and then there's some free response questions. You don't need to know about how many points everything is worth, because you're just going to get a 5, a 4, a 3, or a 2, or a 1. And of course, we all know you're going to get a 5 or a 4, right? Anyway, so that's how that works. One thing I do want to mention is that of the 50 multiple choice questions, the first 45 are slightly different from the last 5. These ones have 1 right answer. First 45 have 1 right answer. And then there will be, big bold letters, and it'll say, now the last 5, 46 through 50, are different. They have 2 right answers. So you're going to have to bubble in 2 things. If the right answers are A and B, and you bubble in A but not B, you get it wrong. If you bubble in B but not A, you get it wrong. There's just 1 point for these, and you have to get both of the right answers. So when they tell you there's 2 right answers, pick 2 answers. And I'm going to talk to you a little bit about what those questions might be like. I will also say one quick strategy for squeezing out all the points you can get. When there's 1 or 2 minutes left in this 90 minutes, it's probably a good idea, if you have not yet finished, just to go through and bubble in something for each one of these 1 through 45, and then just bubble in 2 for each of these you have not finished. Because if you get it right, there's a point. And if you don't get it right, it's not like they're going to subtract. Leaving it blank and getting it wrong count the same way. So don't leave anything blank. All right. So that's the multiple choice. and that is the free response. So what I want to spend a little bit of time on now is explaining to you what kind of problems in physics involve two right answers. And I'm going to use this as an opportunity to review some of our kinematics. So let's say we have a word problem that sounds like this. A ball is thrown upward with a speed of 30 meters per second. So this problem is not talking about the ball's at rest and somebody accelerates it to a speed of 30. That all happens before the problem begins. This problem begins 0 to 30 at the moment the ball is released. The moment the ball is released from someone's hand, its initial speed is 30. All right, and there's all kinds of things we could ask, but one thing I could ask is, after how much time is the height of the ball I just want to see 20 meters. So after how much time is the height of the ball 20 meters? And it's implied, that that's 20 meters above where it starts, because we don't know how high it was at the beginning. So I want the ball to have risen 20 meters from the point of release. Interesting. So what would be a great idea right now is for you to work this problem out on your own and see if you can get the answer. I have implied that there might be two right answers to this question. There might be two times, 5 seconds and 37 seconds. So press pause, see if you can do the problem, and then when you've either finished or when you realize what your question is, come back to the video. So hopefully you paused and you've gotten the answer. Let's see how you did. This feels like a kinematics problem to me. So I'm going to write the initial, the final, acceleration, time. I could write X, or I could write the letter Y, just to make it really explicit for people who are reading that we're moving vertically. But it's fine if you wrote X there instead. And let's see what's given. The ball is thrown upward with a speed of 30 meters per second. That's the initial. I want the final height to be 20. So I want the vertical displacement to be 20. I want it to go up, 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 up 20 meters. Might keep going, but I want to know after how long has it gone up 20 meters. And because the object is in free fall, the acceleration is negative 9.8. Remember last time we said in free fall, the acceleration is negative 9.8 meters per second squared. It's implied that the upward direction is positive and the acceleration is downward. And that's why I write negative 9.8. If my velocity and my acceleration are in opposite directions, they have opposite signs, that's going to cause things to slow down. And that makes sense. I throw it at a speed of 30 meters per second, and it slows down, eventually stops. I'm not going to say V final is 0. I don't know the final velocity because I don't know how fast it's going when the height is 20 meters. Okay, so I'd really like to know T. Is there an equation that does not have V final in it? Yes, there is. X equals the initial T plus 1/2 AT squared. 20 equals 30T plus 1/2 negative 9.8 T squared. So I wrote my 5 kinematic variables. I did not write the units in here because when I don't write the units, it is implied that they are the correct MKS units. Displacements in meters, velocities in meters per second, accelerations in meters per second squared. And I don't have to write those units in here either. That would just make things look really crowded and muddled, and it would obfuscate the meaning. So I want to solve for T. So I'm going to take 1/2 times negative 9.8 and get negative 4.9. I'm going to move that to the left side so that I have a positive coefficient there. 4.9 t squared. I'm going to take this 30t and move it to the left as well. Minus 30t plus 20 equals 0. And now I have an equation with t and t squared. I have 0 on the right side, so I can use the quadratic formula to solve for t. And that's how I'm going to get 2 answers for t. T equals negative b plus or minus the square root of b squared. Negative 30 times negative 30 is positive 900 minus 4a c all over 2a. 2 times 4.9 is 9.8. I have a square root. I hope that underneath that square root, I have a positive number. If I have a negative number under there, that means something impossible is happening, because I would have the square root of a negative number is imaginary. So I'm hoping that 4 times 4.9 times 20 is smaller in size than 900, so that underneath the square root, I have a positive number. Let's see. 4, 4.9, 20. Yay, 368. So 900 minus 368 is 532. I'm going to take the square root of that and get about 23. So I'm going to say 23. 30 plus or minus 23 over 9.8. All right, that's 30 plus 23, 53 over 9.8, or 30 minus 23, 7 over 9.8. And I'm just gonna get really quick numbers here. 53 over 9.8. 53 over 9.8 was 5.4 seconds, or 7 over 9.8. 0.7 seconds, 0.7 seconds. I rounded them both to the tenths just because I felt like tenths was nice. So there's 2 amounts of time. Which one should I pick? So many times when we have 2 answers, we just throw away the negative one, but these are both positive. What's that mean? It means there's 2 answers. They're both right. Let's go back to the question. A ball is thrown upward with a speed of 30 meters per second. It's going 30 meters per second. After a second, it's going about 20 meters per second. After another second, it's going about 10 meters per second. After another second, it's just about stopped. I'm saying just about because I'm pretending 10 instead of 9.8 as my negative acceleration. After how much time is the height 20? Can you visualize what's happening? Go. There are 2 moments when we reach a height of 20. Go, and it gets to a height of 20, but it's still moving. And so it goes up, 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 and stops. And then it falls. Ooh, and then it gets to a height of 20 again. So 7.77. 0.7 seconds, 7/10 of a second after I release the ball. It's 20 meters above where it started. And then it goes higher, 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 and stops. And then it falls down, falls down, falls down, gets to a height of 20 meters again, 5.4 seconds after we started. And then it falls and hits the ground. So we reach a height of 20 2 different times, on the way up and then again on the way down. And that's why there are 2 answers. So this is the kind of problem where there are 2 answers. So if the multiple choice answers were A, B, C, D, and E, and it were 0.7 seconds and 1.3 seconds and 8.5 seconds and 5.4 seconds, I don't know why they're in a weird order, and 27.1 seconds, well, 0.7 and 5.4. I would pick both A and D, 2 answers. There's all kinds of things in physics where something happens twice. right? So at what time does it have this height? It has that height twice, once on the way up and again on the way down. What if I'd said, at what height does it have a speed of 25 meters per second? Well, it's going 30 and then 25 and then 20 and then 15 and then 10 and then 5 and then 0. And then it's going 5 meters per second down, 10 meters per second down, 15 meters per second down. But the speed is 5, 10, 15, 20, 25. Ooh, so there's also 2 different times when I have a speed of 25. So that would be a different problem you could do. So this is a great example of a 2-answer problem. If you'd gotten one of them right and one of them wrong, you'd just get it wrong. So if you'd put one right answer and left the other one blank, you'd get it wrong. It's just either right, A and D, or wrong, not A and D. So be sure that you do pick 2 answers. If you run out of time and you get one of the answers, bubble that and then guess on the other one. But definitely put a second bubble. Okie dokie. I hope that makes sense. Feel free to write down a question and ask it in class if something here needs clarifying. Okay. So that's the way of understanding what 2 different answers mean. So there's always some physics meaning to that. What if I gave you a table like this? Velocity, acceleration. And I had different possibilities. What if both velocity and acceleration were positive? Or what if both velocity and acceleration were negative? Or what if velocity and acceleration, we had one of each, one positive and one negative, or the other positive and negative? Can you model with a toy car? Or could you get up and walk or run around and model these situations? I bet you could. And that would be a great thing for you to press pause right now and do this. Get some motion in. But what does it mean to run or walk and have positive velocity and acceleration? What does it mean to skateboard and have both negative velocity and negative acceleration? What does it mean to move across the room in your wheelchair and have a positive velocity and a negative acceleration? What does it mean if you're doing pull-ups to move up with a negative, or to move down with a negative velocity but still have a positive acceleration? Could you model all 4 of those situations? Press pause now and give it a try. And I really hope you're back. I hope you went away and came back. And so here's, and let's call these A and B and C and D, just so we can talk about them. What if I asked you which rows represent speeding up? Which I like to joke, and I call that fastering. Is A fastering? Is B fastering? Is C fastering? Is D fastering? Which row or rows represent or represents fastering? And I hope you picked both A and B, because I said last week, if the velocity and the acceleration are in the same direction, that means the thing is increasing its speed. Remember that? What if I said which row or rows represents slowing down, which I call slowering? Well, it's kind of obvious then that these 2 rows, C and D, represent slowing or slowing down. And I did this. And that just, when you're old and your back needs a little stretching, that feels really good. So if the velocity is in one direction and the acceleration is in the other direction, whatever those 2 directions are, as long as they are opposite of each other, the velocity's direction and the acceleration's direction, then the object that is moving thusly will be slowing down. the magnitude or size of its velocity will decrease. Is there another to-answer question I could ask based on this chart? Sure, I could say, which of these A, B, C, D would represent an object moving down or to the left? Assuming up and right are the positive directions, which of these would represent an object moving down or left? Well, then the answers would be B and D. A negative velocity means we're moving down or left. Which of these columns, goodness gracious, it's hard to talk and read at the same time. Which of these rows would represent an object moving to the right? Well, that would be these two rows, A and C. Maybe you could come up with an additional question that would have more than one answer. That would be great if you could write it down and share it in class. And that represents the end of today's lesson. If you have any questions, that makes perfect sense. Sometimes students get really specific with their questions and they say, hey, Dr. Platt, when you were 16 minutes into the video, you said, that's great, that's really specific. You can do that. Or you can just say, hey, I was wondering. I love it when questions start with, I wonder. I feel like that creates a positive mood. So try practicing that too. Start your questions with, I wonder, creates a positive mood. Have a wonderful, wonderful day. And thank you so much for thinking about physics with me. Bye-bye.